My name is Jonathan Bahai. I am the president of the Pure Plays Blockchain Standards Association. It is an organization that's dedicated to purely fair gaming, and I have been in the blockchain industry for over 5 years. And today I'm going to be talking a little bit about the inner workings of how blockchain works here with Kelly.
Hey, so my name is Kelly Cadell. I'm a bunker supervisor here. I take care of attendees and make sure they always have a great experience.
So Kelly,
Yeah.
have you heard about cryptography?
I've heard the word, the name, but I don't know what it is.
You don't know what it is?
No.
Okay, so have you heard about cryptography? Because cryptography is where it all begins for blockchain. Okay, so essentially cryptography has been around for a really long time. Okay, so it's nothing new, but it's something that is really well proven.
Okay.
And as a matter of fact, it's been around even as old as bunker. You know, like back in the day when this bunker was operational, it used cryptography.
Cool.
All right. So back then, essentially cryptography, what it does is it allows you to be able to ensure that the data that you've stored has not been tampered with.
Okay.
It allows to ensure that the sender and the receiver of whatever information you want to send or receive has not been tampered with, and you're ensuring that the correct sender and the correct receiver are actually getting the message.
Okay.
Right? So, for example, back in the day when the bunker was operational, we used it for being able to send messages to the military. Right? You don't want our messages going to the other guys.
No.
Right? Not a good idea. Bad idea, right?
Yeah.
Using cryptography ensured that when our guys got a message, they knew it was coming from the bunker, and when we got a message from our guys, we knew it was coming from our guys.
Okay.
Right?
Yep.
So if we couldn't do that, it would just be total chaos. So for a really long time, we've had cryptography, and it's been working great. And as a matter of fact, as the internet has evolved, more and more of our applications are using cryptography as well. But we're using it in different ways. So, for example, you may use an application like WhatsApp. Have you ever heard WhatsApp?
Yes. Yeah.
Okay. You guys probably use WhatsApp too, right? So essentially WhatsApp, what it'll do is every time you're sending and receiving a message, you're actually using cryptography. Okay? So there's several elements to that.
Yeah.
Okay, so first you have to have a sender. Okay, so that's an identification of the sender.
Yeah.
You have to have a receiver, identification of the receiver.
Yeah.
You have a verification algorithm. Okay, that's going to make sure that everything is working right. You have a public key. We talked about those before.
Yeah.
And a private key.
Yeah.
We talked about those before.
Yeah.
Okay, and then you have something called a hash.
Okay.
It's not the hash you're thinking of. Not you either. So what it is a hash is almost like a fingerprint.
Okay.
Okay, so you're putting a fingerprint on whatever it is that you're sending, and then that way the information is unique.
Yeah.
Okay, so every time, for example, in WhatsApp, when you've created a message, and what's happened is that the message has all been taken with your information and with your private key, and it's all been bundled together, and then and then the public key of the sender or the receiver that you want to send it to is all bundled together, and then a hash is put into that data code.
Okay.
So that fingerprint's put in, and then it's sent off. Okay, so every single message is unique.
Yes.
This ensures that when the receiver of your message has all that information and they decode it, it's unique, and it was from you to the other person, and they got the correct information with nobody tampering with it. So it's pretty amazing.
Yeah. So that's a pretty cool security thing. I know you've taught me about public key and private key in previous episodes. How do those come into play in cryptography?
Okay, so in blockchain, what we have is what's called cryptographic public key cryptography.
Okay.
So what happens is that essentially you use private keys in order to send and receive information, and in order to ensure that the information that's being stored has not been tampered with.
Okay. Yeah.
Very critical to a blockchain.
Right.
So essentially, there are certain elements that all go into whenever a block is produced in the blockchain, and that uses these public and private keys. Okay. You have the public key, which is free to be able to share with anybody.
Yeah.
You have the public key. You have the private key,
Yeah.
which you keep to yourself,
Right.
which nobody is able to see except yourself. You have a hashing algorithm, a verification algorithm,
Okay.
which is going to verify that all the information within the packet is correct with with the correct private key, public key hash, and then you have the hash, right,
Okay.
which is the unique signature of the
Your
data,
fingerprint.
which is produced depending on the type of data which is going into that particular block.
Right.
Okay.
Okay.
So, so the public key and private key are all used together to create all of that. All right, and that is what is used within the blockchain.
Okay.
So it's really technical, but that's what's happening all the time, and that's how cryptography is being used in blockchain.
So when you say public key, can I give my public key to anyone?
You know what? You can. Public keys you can.
Okay.
Private keys you can't. I think you remember in the previous episodes.
Yes.
Right.
Yeah.
Actually, I think it was the last episode. We talked a little bit about your house and being able to have a key to your house. But then there's also the key, and then there's like everybody who's your flatmate will be able to have a copy of that key to get in the house.
Right.
And then you have your private key, which is for your room only.
Right. And I'm the
Right.
only one who has that.
And you're the only one that has that, right?
Okay.
So everybody is able to come and go from the house, but they can't get into your private room. So that is something. That's the difference between a public and private key. We talked about that in the last episode.
Right.
So with that, you'll be able to ensure that you can give your public key to anybody.
Yep.
No problem.
Yep.
As long as you keep your private key private,
Okay.
you're good.
So, if I'm correct, the message cannot be tampered with if using the hashing algorithm.
Exactly.
Okay.
You got it.
Awesome.
So as a matter of fact, this is where the signature verification, the signing verification algorithm,
Yeah.
the hashing,
Yeah.
all come into play. Okay. So for example, the algorithm that's used in Bitcoin is called SHA-256. This is where that algorithm will take whatever data it's been provided,
Okay.
and then it produces a hash out of that.
Okay.
Okay. And then the hash is going to be unique, so that no matter what computer you run it on,
Yeah.
okay, you can run the same data on multiple computers around the world, and it's always going to come out with the same result, right? It's always going to come out being able to unencrypt and be able to see that, okay, this information is the same.
Okay, so can somebody add like a new word to the existing data?
No. And so the reason why is because let's say that they even added a period or a space,
Yeah.
or they changed the message from I love you to I hate you,
Yeah.
or anything like that,
Yeah.
then the entire hash is going to change.
Okay.
Okay. So because the data package, once the data is verified, it is locked,
Okay.
right? And so then if you change the hash,
Yeah.
that whole thing changes, and then when the when the signature verification algorithm kicks in,
Yeah.
and it sees that it's not the same hash,
Yeah.
then basically the you can't unlock it with that key anymore,
Okay.
right? So it's just like it's been locked, it's set, and then if you try to unlock it and if you try to change it, then it's a completely different combination now,
Okay.
and so that the private key and the public key aren't going to work the same anymore, right?
Right.
So if you send a message and it's somehow a hacker intercepts it, they're just going to change it, and then what's going to happen is the signature verification is going to reject it,
Yep.
and then they're just not going to get the message, right?
Right.
So in that way, it's secure. The same thing happens in the blockchain. So every time, let's say that there's data written to the blockchain.
Yeah.
If anything happened to try to change it in any kind of way, then what happens is the ledger just rejects it.
Okay.
And anytime that there's been attacks on the public ledger of Bitcoin itself, this is what's happened. The ledger just rejects it, it's gone, and then only the verified, because it's been verified through all the process that we've just been talked about.
Yeah.
That is what makes it into the ledger. That is what keeps it secure, and that is why blockchain is what it is. And so it's nice and secure. It works, and it's verified. It's all good.
It seems very, very secure.
Yeah.
Yeah, so thank you for teaching me about blockchain today. I know I still have a lot to learn, but we'll do that in upcoming episodes.
And thank you for your great questions and
I'm
trying to understand all of this.
Yeah.
And appreciate all of you trying to understand all of this. If there is any questions that you have, feel free to leave a comment below. I'll be happy to answer them I'll try to answer your questions the best I can in the next episode maybe, and then we'll be able to learn more about blockchain. So until then, This is
Smash those lights.
Smash those lights, ding that bell, and join us again here at the Coin Frenzy Bunker.